Okay guys, I know it's been a long time and I didn't end up really putting out the videos about this fixed gantry mill like I planned, but I thought I'd go ahead and give you an update of where I am right now. It ended up taking longer and it's been stretched out more over time. It's still going well, it's going as planned. It's just been a little different than I originally imagined. So I don't have any video footage of the building process, but I thought I'd give you guys just a quick look at where I'm at. I'm about 80% there, and I'm getting down to the little stuff now. And so I just thought this would be a good time to show you before the completion, and then maybe I'll get another video out of the actual completion. So here we go, check it out. So this is the fixed gantry mill that I talked about in the last couple videos. I think when the last video I showed this x-axis and z-axis just partially in mock-up. They're now to a much more finished stage with all the holes drilled. This plate was surfaced. Of course, all the ball screw mounting. These blocks, a lot of this top portion has been painted already and it's done. This block and these towers are obviously done. So I'll just give you the quick run through here. So we'll start with the Z-axis. So the Z-axis this is cast aluminum plate on the front. I'm running a 4 kilowatt spindle here with a, let me see, I can't remember off the top of my head, I think it's ER25, call it. Yep, you can see there, ER25, so that gives me the ability to go up to 3/4, I believe. I end up getting this spindle off of Amazon. I was gonna just get a 2.2 because of the price, but I got a really good deal on this and it's air cooled, which I'm really glad about that because I don't have to deal with all the coolant system, which is just another thing that you have to deal with and come up with. And there's already just so much involved in something like this that you do get to a point where you want to simplify things as much as possible. So eliminating that spindle coolant system is a good thing. So like I said, this is attached to this cast plate. Obviously there's countersunk screws under the spindle that attach this to the ball nut. The linear bearings attach here. You can see these sets of holes, four here, down here, and over here, of course. Okay, and I'm running HSR 15 rails, THK, I think is the brand. And I may have gone over some of this before, but I'm going to go over it again. Typical ball screws. This is the motor mount situation that I ended up with, and this is one of these pre-bought motor mounts, a NEMA 34 mounts. And it's just got the correct spacer behind it to align it this way in this axis. And let's see here, and I'll grab a motor and just kind of set it on there for you guys. So motor looks something like that right there, setting up there. And yeah, I went over these before too. I think they're a little over 800 some ounce NEMA 34s, but a short body NEMA 34. So that pretty much covers that axis for now. You can see where this Y axis or subplate would attach to these LH25, I think is what they are, rails, NSK. And so, like I said, this whole plate was surfaced. I ended up surfacing the whole thing flat. I mentioned before just doing pockets or just areas. I ended up having to do the whole thing because of just the milling process. So also I want to mention that you can see that right there. Of course that's painted over, but I filled both of these top towers here, this tower and this tower, as well as this. You can see that that's been filled. It shrunk back a little bit, but that's all filled with epoxy granite, or my version of epoxy granite, which is just epoxy mixed with sandblasting media. So that worked out pretty well. I think that'll help the vibration dampening. Okay, let's move on to, well, we'll go over here to this motor mount. This motor mount ended up changing and morphing as it went. You can see I had the 4 holes here, which would have been your normal 1/4" holes. But because I end up having these, that design just changed a little bit. So I end up doing 2 slotted holes here and bolting it, but I end up actually just welding it because I just didn't feel like these 2 bolts was enough. So anyway, so that's that. And again, this has these rosette welded countersunk screws, and I'm using those Allen nuts to mount the motor. So that's that. So we'll go down here, and so some of this stuff that I didn't explain before, I didn't have any of this stuff done. So these right here, all 1/4" wall 2x3 tube, the whole substructure is made out of that tube. These all have end plates put on them, and every single one of them is milled, perfectly in length and flat and square on the ends. These ones to the edge have this area milled out right here, travels from here back, and that's where that milled tower sets on and bolts on, and these are 5/8 bolts. Of course, they'll have lock washers. This is still just a mock-up because I've got to figure out my limit switches and all my way covers, to cover everything up. So it's just kind of in a mock-up stage still. So go over here, same thing on this side. I want to go over these real fast because you're probably wondering what these are. So these right here I thought of because they do 2 things. They triangulate these towers, which are tall towers. The farther up I could get this, the better. But this is about the position that I landed on. And these help triangulate this tower to give it structure this way. But also, one really big benefit is to give me a slight adjustment in tram. So if everything on this is going to be adjustable to some degree. Everything is milled, but if I need to adjust the tram, we're talking a few thou, as I tram this mill in, then I have the ability to crank these things up, tighten that or loosen that, and that should tram that tower on each side and give me just a little bit of adjustability. So as you can see down here, these are all painted, by the way. This is all painted. I still have to get jam nuts for these and bolts, 1/2" bolts that go through here. But anyways, these are painted. This is the same LH25 rails here, and that's where the table will mount. And so I end up kind of changing my design on the way this ball screw mounts. I end up just going with aluminum blocks with big through bolts through the end, or through the wide part of the block right into the side rails. And that seemed to work out as good as anything. I did have original design kind of had this plate going across and attached to these 90-degree brackets here, but that interfered with these bolts here after I kind of seen it in real life. I modeled most of it up in CAD, and I have everything crucial in there, but there was some of that stuff that I just didn't catch like that I ended up changing, and like this motor mount over here, I didn't really model that up fully and kind of bit me. So anyways, one more thing that I need to do is mount this bracket, motor bracket here, and probably all I'm going to do is just build like another 90-degree bracket. If you could just imagine this with solid steel, it would just be another bracket that would be attached here so that this one could be attached to that. Then you'd have some adjustability this way. I actually need just a little bit of adjustability this way because it's pretty tight if it's all the way flush against that surface. So that's that. This here is just 2x2 here, just a thinner wall just to connect the bottom base legs. Let's see, well, to give you just a wider view of it, all the axes, or the 2 axes that I've got hooked up, are really smooth and work well. Right now I'm working on, I'll show you what I'm working on. I'm just going to set this camera down for just a second and grab something. So Bellows, that's what I've been working on, and thinking a lot about, doing a lot of research, trying to figure out the best way to go. So if you've looked into this at all, there's a lot of Chinese options out there. That's the only options that I can find, besides some industrial places in the US that make custom bellows basically. Well, I don't want to order from China right now with the whole virus thing going on anyways. I don't want to wait a long time. I don't want to try to communicate all the dimensions that I need. So I got to digging in and discovered, like if anyone's looked into this, they probably ran into a little website, I don't remember the name of the website, that a guy wrote this very basic little program to give you the dimensions and the layout that you needed. So initially, I did one of these in paper, and just kind of got the hang of how it works. Well, then after I did it in the paper, I wanted to get I wanted to make the real bellows. And then I ran into the wall of just trying to find the correct material. And I never did find any recommendations or real information on it. I seen, mentions of rubberized fabric and just different things, but nothing specified, nowhere to get it, no idea what they really use. And some of them just use a basic material, like some Chinese machines. My dad's got a Chinese mill. It's got one bellow on it that's got a very basic cloth type material, like a backpack type material. So anyways, I did tons of research, found a source for this stuff, and this is what you would call a rubberized fabric. And you can't see both sides. Well, here, I'll actually show you the flat. Excuse some of the mess on the floor. I'll show you it flat. Now here, initially, this was this initial paper pattern. It's been unfolded because I just used it to draw out the pattern on my actual bellow. But this is what this material looks like. So on one side, it's still rubber. It's rubbery on both sides, but it's kind of a flat, non-patterned rubber on one side, and a more of a patterned rubber on the other side. But it's material in between. It's fabric. So that gives it the ability to actually fold and stay folded. Gives it some strength as well, because just regular rubber, when it gets folded a lot, it will actually give way and crack and bust and tear. So I searched high and low and had to just order some stuff and shoot in the dark, and finally I came up with this stuff, which is amazing. I couldn't ask for any better. But I'll give you a quick rundown on how I did that real quick. I want to try not to make this super long. So what I did was I basically took that material and I glued a craft paper to it, just your typical what they call craft paper with a K, duck brand. And I glued that to the back of it with upholstery. I've done some upholstery in the past, so I have some real good high quality upholstery glue. And I glued that paper to the back of that material. And then you can still see some of the faded pattern left over. And I actually drew out, I don't know if you can see that, yeah. You can kind of see some of the draw lines there, some of the pencil lines, I mean. So I used that craft paper for two reasons. Something to draw to as I laid out my pattern, as well as something to just help keep a fold with that paper backing. Just kind of helps it keep a fold. So this is something I figured out on my own. I had no help on it, but I got to tell you, it turned out absolutely fantastic. In the video, you can see it might look a little bumpy or whatever, but it's just really fantastic. It holds the folds really well. And I'll give you a quick idea. I don't have any of the plates made or anything for this yet, but give me just a second here. Well, you still can't really tell. But anyways, see, this will have two plates on the ends that actually attach it to here and to this aluminum plate. But you can see that that's what that's going to look like. And these ends will obviously be held at square 90s with the plates on the ends. And you can see that will scrunch up here at the top, and that will give me that will end up wrapping around. You know, it'll attach to this and wrap around this part here and cover everything. And I'm also going to have some steel pieces either on this or on here that just kind of helped contain that and just kind of help also keep some chips away. But anyways, that is the homemade DIY bellows, which are probably a little higher quality than all your standard Chinese bellows. It's a really tough material. I think it's going to work out really well. So I've got to make 2 for each end of this, and then down here on the table, I'm not sure exactly what I'm going to do yet. I may do a metal type of weight cover because of the size. I don't know that yet for sure. So anyway, so there's something else here I want to show you guys. And so, if you know anything about CNC, I should have moved this earlier, but I didn't. Use the tools. If you know anything about building your own CNC, one of the biggest things is the control cabinet, where all electronics are going to be, and just all the wiring. The wiring's a big deal. And one thing that's also a big deal is shielding the crap out of everything so that you don't have any interference problems. And that's something I wanted to do from the very beginning. I didn't want to fool with it. I didn't want to think about it. I just want to know it's good. So I did that. So this, I just took this box. I built it out of actually a piece of scrap. Let me roll it around. See here. I'll give you a shot of that. So that will be this. What you're looking at, this end will actually be sticking up, and that'll be, you know, it'll be sticking up. So you'll have your on/off button and your e-stop right here. And I'll show you inside. This door is not attached yet. So we're just going to set that off. Okay, so you can see in here, it looks a little messy. I tried pretty hard to make it all as neat as possible. A lot of wires, especially done this way. So with this Chinese kit, it has 3 power supplies, which is not ideal. But I did go with it. It has a lot more excess wiring and stuff. I got 2 big PC fans here. Power comes in here, fuse holder. All your neutral and your hots get split here. All your grounds come back to this one ground bar here. You got a 5-volt power supply and a 12-volt power supply. 5 volts for your breakout board, 12 volts for my fans. Of course, each power supply drives the drives. Shielded wire here, which goes to your motor connectors. They're just wrapped in kind of a loom. Of course, this is your power coming back. E-stop here. This is my on and off switch. Right here is the breakout for the 5 volts. And of course there's your breakout board, and this is just another splitter for your common on your inputs. Yeah, your inputs. These are step and direction wires. These are using the ferrite on both ends to eliminate the electromagnetic interference. So ferrite here, shielded wires here. This is shielded here. Everything that needs to be shielded will be shielded. So that's that. And I'll go ahead and show you. I end up buying this used. This will be my spindle cable and power wall cable if there's enough. I end up buying it used. The stuff's really expensive, but it's double shielded. It's got like your regular foil shielding. Sorry. And then also your tin braided copper on the outside. And so it's got a couple extra wires in it, more than I need, but I didn't think that'd be a problem, so that's what I'm going to go with. These are my limit switches, which they're very basic limit switches. They're Omron. I forget the number. Right, here we go. V156 1C25. They're just your typical standard roller switch. They're cheap. The reason I did just go with cheap ones is because I don't plan on using them for any purpose. They are just safety switches. Hopefully I never even run into that issue at all. But in case I just make a mistake and I go past, all they are limit switches. They'll all be tied in series, I believe. That's the term. They'll all be tied together, so they all go to the same input on the board. And if any one of them gets triggered, then it just alarms out on Mach 3 or UCNC or whichever one I'm going to use. These here are, this here will be used. These are these, if you pop that open, it's a DB9 connector, you pop that open, it's got screw terminals. And this will be in the enclosure for all my inputs, and that's how I'll come in and grab the inputs. Just one nice big connector, and I can get all the inputs in one connector. And a lot of these suggestions were from a guy on YouTube, goes by Corvette something, but his name's Vince, and he sells a lot of product, and does a lot of videos and stuff, so he's really particular on shielding and all that. So anyways, so let's see here. I don't know if there's anything else right now. I've got, like I said, I've got more bellows to make. I've got limit switches to mount. I'm going to actually try to drill and tap these, at least on this axis on both ends, to put my limit switches here, if that's possible. I don't know how hard this is. And then I still have to figure out some limit switches on everything else. But yeah, that's pretty much the quick basic rundown. Turn this back around. Yeah, that's pretty much it. I mean, you know, it's going pretty well. Like I said, it's taken a little longer than maybe I wanted it to, but it doesn't surprise me at all. I knew it'd be a long, drawn-out project, but I just want to do it right. I want to get it right the first time. And one thing I want to accomplish is try to make this as professional as possible and try to make it something I can depend on, rely on, not have to fool around and muck around with stuff all the time. I want to buy a pendant. I still have to buy the UC 100 to convert the parallel port off the breakout board to USB. Let's see, I still have to build the table, obviously. I didn't mention that, but the table's not built yet, and I actually came up with a pretty good idea. I was going to just order a pre-made, pre-milled T-slot table. They end up being a little thinner than I wanted to be for the kind of money I wanted to spend. So I came up with a pretty sweet design. It's like a multi-piece design, and that way it's got a lot of advantages. It's pretty reasonably priced. The downside is I have to do more work to get it, obviously, because I have to, basically it's just a 1/2-inch steel plate the size of my table with all the holes to attach it to the bearing blocks and to the ball screw nut housing. And all those will be below the surface, below the top surface flush, and then a bunch of individual 1 inch high by 1 3/4 or so aluminum extrusion. Not extrusion like a typical extrusion. I mean just solid stock, 6061. And that will run the width of the table, but they'll be bolted down to that steel plate, but they'll have milled channels on each side. So when you bolt them down, they all create T-slots to each other. It's kind of hard to explain. I know I didn't do a very good job explaining that. But basically it's just a bottom steel plate with a bunch of aluminum pieces attached, bolted to the top, and those aluminum pieces, because of the way they're milled on the bottom, they create the T-slots. So the big advantage there is I can just surface that aluminum. I don't have to surface the steel plate, nothing. I'll bolt it all on there. First thing I'll do when I get this thing up and running is to surface the whole top of that thing. And then, you know, I can surface that again a few times, and if something ever happens, I can just replace those aluminum pieces, those aluminum blocks, and surface it again, and then I have a new table again. So that's kind of the advantage, and it's pretty reasonably priced. It's pretty reasonable to do it that way. So that's what I'm going to do. Well, probably I might, if I get a chance, I might do a video of me actually folding those bellows and building a bellow, because I think that's something people would be interested in. So anyways, that might be coming, and I want to definitely show after I get everything together. I want to talk about one more thing, is the enclosure. I'm going to have an aluminum closure with plexiglass doors on the front, because I really want to just keep the chips contained, because I know it's a big deal. This thing's going to be flinging chips everywhere, so I want to keep those things contained. But anyways, other than that, you know, it's going pretty good, and one of these days I'll have it all together and I'll come back and I'll show you guys. And I appreciate you watching. I'll see you next time. Thanks. Bye.